Hello guys, I guess we are live now. Can you hear me properly? We are live. Fourth problem, really hard work. Uh, it might be, but I will show you how to do that. Okay, in a really easy way. Okay? So don't take stress about that. Okay. Okay, so we will wait 1 to 2 minutes. Then we will start contest discussion. Okay. Mhm. How many questions did we made in the contest? Two. Why not the third one? Can you write your thought process in the comments, like what you were thinking at the time? First what problem 2 pointers. It was of sliding window, not standard sliding window, but can I say a little tweak was there because of two conditions, right? There were two constraints at exactly k and that one greater than equals to m. So there were two constraints on that. Okay, so let's start with our post content discussion now. The fourth one, I think. Oh, okay. This is a standard idea. I also thought that if you go through my like solution video, you will see that I was typing this at my function k minus my function k minus one, but this don't work. Okay, because of the second constant, you need to have at least that m. That's why. They was tough for me. Third one is more on bit inclined, so I guess that's why, but it's not very hard. And part made it difficult. Yeah. The second constant was making it difficult. Else you can do that with the standard sliding window with exactly k thing where you go at most k and at most k minus one and take a difference that you will get exactly k. Yeah. Okay, so this is the first problem, quite easy and straightforward. You are given a string S that contains lowercase English letters. Return the string obtained by removing all trailing vowels from S. The vowels consist of A, E, I, O, U. So, do I need to explain this? Is there anyone who was not able to make this? Okay. So, for this one, you can see E and A are trailing vowels. So, we will remove them. Then the string will become I and D. Here, there is no trailing vowels. The last one is Y. Here, all of them are vowels, so I will remove the complete string. That's all. No need for explanation of this. So just what you need to do, just straightforward, make a pointer at the last, then keep decreasing it until you get vowel. So you will keep decreasing it, else you will break out because you got a constant, and then you can just return the string. Okay. Second problem, just return n into n minus 1 by 2. I am not able to see it like, because of that heart emoji right there. What is written into n minus 1 by 2 divide minus n. Oh, okay. I did dp for second. Yeah, dp is the main idea, but you need to take care of one more thing. Okay, so let's just give it an idea for the first one because the videos will be uploaded on YouTube also. Okay, so if you are given with any string which contains vowels at the end, okay, how you can remove this? You can make a pointer over over the last index and keep decreasing your pointer until you get a consonant. Okay? And when you get a consonant, break it out. So your pointer will be pointing something like, if you have A, B, C, D, E, I, O, U. So then you go U, then you go O, I, and E, and then D. So your pointer will point here. So now you can return this substring. So return this substring of 0 to that pointer, say pointer plus 1. Okay. So that's how you can do the first one. Second one was greedy DP. It was more inclined on DP approach because you are maintaining states. If you think start from fourth, okay, we have to go from like fourth to first. People will leave then at the third question. Okay. Right. So the second problem. Okay. So in this one, as you can see, you are given an integer n, and in one operation, you may split an integer x into two positive integer a and b, such that a plus b is equals to x. The cost of this operation is a into b. Return an integer denoting the minimum total cost required to split n into n once. Okay. Alright. So your cost is a into b. Okay. When you split x into a plus b. Alright. So let's take some example to visualize how the thing is working. Okay. A into b plus fx plus fx fn minus x. Okay. Yeah. Okay. So I want to make one theory on this question, that however you break x. Okay, so if x is 25, if you break it 24 1, or you break it 25, or you break it 15 10, or anything else. Okay, anything else, the answer for all of these breaks will be exactly the same. Okay. Okay, so there, this is my theory. Now let's prove it. Okay. Right. So what is the basic easiest way to break it? Okay, so I can break it in one digit is 1 and other one is n minus 1. Okay, so the total thing that I will get is n minus 1 into 1. Correct. Total cost. Now break n minus 1, so it will be break down into 1 plus n minus 2. So now the total thing is n minus 2 into 1, and you keep going on for n minus 2 and so on up to 1 plus 1. Then the total cost will be 1 into 1. Okay? Yes, I am able to do classic in out DP in code. I'm not able to do this critical ad hoc. This is an ad hoc problem, more inclined in ad hoc side. Sometimes you just look at, you should look at test cases, then you can get the idea like, oh, three for answer for 3 is 3, then answer for 4 is 6. There is some logic in that. You will get the idea from there. Okay, so as you can see, if I break 25, it will become 1 plus n minus 1. And if I break n minus 1, it will become 1 plus n minus 2. If I break it n minus 2 and keep going down, so in the end, I will get 1 and 1. Okay. So the total cost of 1 and 1 is 1. And if I keep going up, it will be 2, 3, 4, up to n minus 2 and n minus 1. Okay. So the total cost will come out to be 1 plus 2 plus 3 plus 4 plus up to n minus 1. Yes or no? So what is the sum of this series? If it is x, so sum of the series is x into x plus 1 by 2. So I can put n minus 1 in the place of x. So it will be n minus 1, 1 n minus 1 plus 1 by 2. Sorry, this one, break it out. So this will cancel out. So it will become n into n minus 1 by 2. Okay, so this is the answer for my problem. Okay, but I'm breaking in 1 and n minus 1 way. So what if I break it in some other way? Let's take the same example, 25. Break it in 1 plus n minus 1 and so on. So my answer was coming out to be, for this particular way, it was 25 into 24 divided by 2, which is 12. So if you multiply this, it will give us 300 something. That's 304 into 3. Okay. So for 1 and n minus 1 way, I'm getting 300 as my answer. Let's try to make some different answer. So if I break 25 into 15 and 10, okay, so the total cost will be 150. If I break 15, it will become say 3 and 12, and 10 will become 2 and 8. And I'm taking random values. Okay, so now the total cost will be 36 plus 16. Okay. Now break 3, 1 and 2, okay, 12. Uh, let me take this somewhere. Okay, cut this here, paste it here. So I can write it. Okay. Now for 12, you can just do 2 and 10. For 2, you can do 1 and 1 because there is only one way. For 8, you can do 2 and 6. Anything you want. Okay, so the total cost will be 2 plus 20 plus 1 plus 12. And if you break it down, so it will become 1 1. Okay. If you break this down, it will become 1 1. If you break this down, it will become like, let's say it becomes 1 9. Okay. So 1 1 won't break out, it will become 1 1. It will become like 3 3. Take any of the values away. So don't take stress of that. It will become 1 plus 1 plus 9 plus 1 plus 9. Okay, so break 9 down. It will become 4 and 5. 4 5. Now 3 3 will be break down into say 1 2. This also 1 2. Okay. Now the total cost will be 20 plus 2 plus 2. Then you break it down again 2 2 2 3. This will become 1 1. This will become 1 1. So total cost should be 4 plus 6 plus 1 plus 1. And if you keep going on, like it will eventually get to all the ones. Okay. Okay. So the total cost is 1 plus 1 plus 1 plus 2, and then 1 1. So the total cost will be 1. Okay. So now if you add all of them, if you add all of them from here, 150 plus whatever these values are, it will still come out to be 300. Okay. So rather than breaking in this way, I can break it in this manner and formulate it as what I've done here. If I break it and formulate it, I will get an answer of n into n minus 1 by 2. Clear or not? Yes or no? I did could have waste 30 minutes on first. So second, meaning of trailing. Oh, no problem, bro. That happens. Is this clear or not? They should mention what it means. Okay, so leading means starting part and trailing means ending. Let's move on to the next one. Okay, so for this problem, you can see n into n minus n by 2 is the answer. Next, like more English example. Okay. Right. Now this is a really good problem. In this problem, you are given an 2D integer array grid of size m into n. You must select exactly one integer from each row of the grid. Return an integer denoting the minimum possible bitwise OR of the selected integers from the row, each row. Okay. Now, in this problem, you are given with a matrix with multiple rows, and each of them will contain some values. Say this 5, 8, and 10, 9, 16, 1, 15. Okay, so like this is the matrix. It is m by n. Okay, now you have to choose one element from each of the row. Say I have chose 0 and chose 2 and then chose 9. Okay, so I have chosen all these values. Now I want to find the OR of these. Okay, so the OR of these values will come out to be, I guess, 13 or 11. It will be 11. Okay, so 9 is this and 1 0. Okay, so 11. All right. So the OR comes out to be 11. Now I need to minimize this OR. Okay. So if I need to minimize this OR, what I can do? OR is the only bitwise operator where if any of the value is 1, then it will return 1. Okay. All right. So how can I do this? First of all, let's think. What is the minimum possible values that I can do? What is the minimum possible value that what we can do? It is trying to make MSB bits as 0 from start. Then the value will automatically be minimum. Is this true or not? This is my greedy. If I try to make starting bit 0, then it is possible to make like the smallest possible OR. Now how can I do that? Yes, okay, so let me just max it out. Okay, so how can I do that? Say you have a 5-bit number. This is my 5 bits. Now you will try to make this bit 0. Now you have to check, can I make this bit 0 or not? How will you check it? You iterate over all the grid. For each row, try to find any number where this particular bit, say P, this bit P is 0. If you get in one row, then return a flag as true, and for all of the rows the flag should be true. Okay, if any of the row is missing this bit or this bit is 1, then I cannot make a XOR or I cannot make an OR less than or like with a bit keeping this bit as 0. Okay, so what I have said here is like I am trying to make my OR as minimum as possible. So what I will do, I will choose a particular bit and I will check for each of the row that any row contains a single element which has this particular bit as 0, then I will return true, 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 true. And but if any row returns false, this means this bit cannot be a 0 in my answer. That's why I have to make this one. I have to make this one in my answer. And then keep going on for each of the bit. Correct? Keep going on for each of the bit. Check for each of them. Then can you make this 0? Can you make this 0? Can you make this 0? No. Okay. So can you make this 0? No. So your answer will be this directly. You don't have to do any more operations. Okay. Easy or not? Let's try run on some example. Just tell me if you understand till here on. Let me take some example. Say 7, 3, 11, 4, 8, 5, 12, 14, 15, 6, 8, 13, 10. So this is my grid, row and columns. Okay, so this is clear. It was an easy part. Now what I will do, this is my grid. What is the maximum value? It is 15. So there are 4 bits here. Okay. Now I am trying to make all of these as 0. Okay, so as minimum was 0 is the minimum. I will try from here. Can I make this bit as 0? So what is this bit? It is 8, or I can say 2 raised to power 3, third bit, it is third bit. Okay, so it is 8. Let me write it. So let's go for first bit, which is this one. Now check. Can I make this bit as 0? So if this bit is 0, if I take AND these wires. Okay, so if I make if this is my mask, say this is my mask. Okay, I name it as mask, in which the first bit is on, and I will check if my mask ends with all of these values. So mask ends with all of the values. If any value returns 0, which means this bit is 0, because AND returns 0 if any of them is 0. Okay, so I will try to end with all of them. So let's do it. So the first value is 7. You go 1 1 1. Okay, so this bit this AND returns 0. So I can say 7 in the first row. 7 is there. Good. So for the first one, the row, let's name it as row 1, row 2, row 3, row 4. Okay, so row 1 returns true. Okay, now go for the second row. Okay. Now second row, you see 5. Again the mask is 0, as I can say. So row 2 will return true. Now go for third row. It is 2. You don't have to check for all of the values. If you get a single value, break it out. Okay, so you will reduce the number of operations. Now you have to end it. Still mask is 0. I will say row 3 returns 2. Then you go at fourth row. Now you see 1 0 1 1 0 1. Okay, 1 1 0 1. So now the mask is not 0. Okay, so mask is not 0. Okay, so I will not I will check for other value, which is 10. So for 10 the mask is still not 0. Okay, let's check for 4. For 4 the mask is 0. So I can say I will get my values, I can get a single number from each row where this bit is 0. So my answer will contain 0 at this place. Okay, great. Is this clear? Now go for the second bit. Let me write it here. Second bit. Okay, so this time the mask contains this. Yes or no? Now check. Can I make 7? This is not 0. Okay, can I make 3? 3 is 1 1. Yes, I can make this 0. So row 1 will return me true. Okay, so go on for all of them. Okay. Okay, so go on for all of these values. Like for 3 you got for the first row. For 5 you won't get it. For 8 you will get it. Okay, for 8 you will get it. Alright, so but if you take 8 in this value, then this bit will become 1. Yes or no? If I took 8 in my value, like this bit will become 1 or not? Yes, that's what I want to show you, that you have to update your mask also. Okay, your mask will contain 1 at this place because you have already checked for 1. Correct? Is this clear? This is the key point you need to take care of. So that's why I will dry run on all the test cases. Okay, clear. So you need to keep the mask with you. Okay, now if you do with 8, it will not give you like 0. So this is true, and it should not give me 0. Now if you go for 1, it will give you 0. So row 2 returns true, and so on. You can just like go for all of the values now. Okay, so I have explained you everything. which is needed for this problem. Now you can try run on all the test cases and you will just get from row 1, row 2, row 3, row 4. If any of the row returns false, say any of the row returns false, you will put 1 at this place. Okay. Then you don't update your mask because you are not getting any like 0. Alright, so you put 1 at here and then you go on like whatever you get. So this is the minimum bitwise OR. Clear? Okay. So let's look at the code now. Is this smaller or like I can just increase it? Okay. Right. So in this, as you can see, I made an answer. I made a mask starting with 0, obviously. Now go for each bit from 30 to 1. Right. Now, what is your target? It is like make that particular bit in the mask is true. Okay, make that particular bit as on. Now this is my flag which says I can make this particular bit which is B as 0 in my answer. Okay, this is my flag for that. Let me write it here. All rows returns true. Okay. Okay, so this is the flag for all rows return true, which means I will make this bit as 0. Now you iterate over all the rows of the grid. Then you make another flag which says uh, your row has at least one element with bit B as 0. Okay, I can write it that. So this flag is saying if there is any like element in the row where your flag is true or where your bit is 0. Now you go for each of the values, take a end with that target mask. If it comes out to be 0, then you update your flag as true and break it out. If your flag is false, which means your row don't contain any number where the bit B is 0, so it will return that all rows cannot return true. Okay, so you make this the global F flag as false because it was all rows return as true and break it out. Okay, then what do you do? If your flag is true, which means you can make all the bits as 0, so you will not update your answer. Okay, you are not updating your answer, so it will still be 0, and you update your mask, which I have told you. Okay, so you update your mask with the target mask, and if your flag is like not true, so you cannot make that bit 0, then you update your answer with that particular bit as on. Okay, so that's it for this problem. Is this clear? Is this clear? I guess now it is clear because I've told you all the ideas which are used in this problem. Okay. If yes, then we can move to what is the fourth one. Quite an interesting problem that was. Is this clear? You can just write in the comments, then we can move ahead. Okay. Okay. Let's go into the fourth one. Okay, so in this problem, you are given an integer array nums and two integers k and m. Okay, summarize third one. To summarize third one, what I was doing is I am making my answer. Let's say my answer has 5 bits. Okay, I will go for fifth bit and check for each of the row. Any number of each row contains this fifth bit as 0. I will return as 0. Okay, so I will return 0 in my fifth place of answer. Then go again for fourth one. Check for each row. Any of them contains 0 at this fourth position. I can return 0 for the answer. Okay. If not, I have to make my answer 1 at this place. Okay. 1 at this bit. In my answer, I will put 1 in this bit, fourth one. And same go for third, then go for second, then go for first. Whatever you are getting, like you can make all the bits of third as 0. Then don't update your answer, keep it as 0. Else update your answer with that particular bit marked as 1 and go on for 2. Okay, so that was the whole idea. Alright, so in this problem, you are given an integer array nums and two integers k and m. Return an integer denoting the count of subarrays of nums such that the subarray contains exactly k distinct integers. Okay, you have asked for exactly k distinct integers. Within the subarray, each distinct integer appears at least m times. Okay, so the count of integers must be at least m. Now you have to count the number of subarrays. So this is the definition of subarray. Now, first thought that comes into your mind while having these kind of problems where you are asked for counting subarrays with some condition, the main thing you should come up with is sliding window. Okay, so sliding window is the main approach that I can come up with. Okay, great. All right, so sliding window is the approach that I should take. Now, can't I do like why I can't do like make a map, store all the frequency, like one has frequency 3, 2 has frequency 1, 1 has frequency of 4 has frequency 3. Now these are all distinct values, right? Then I can make I should be able to make a window of size k and then iterate again and again and again, right? Because it is asked for exactly k. But there is one constant only, that the window elements must have like that frequency greater than equals to m, and due to this thing it is possible for your window to look like this. So for this particular map, the array can be look like this. Now you see the ones are not close to each other, so if you move your window, the ones will decrease at some point. Okay, and if your k was like 2, so this is not possible to make 1 and 2 together, because 1 and 4 are together. Alright. You cannot run on a map. Okay. Run your window on a map. Alright, so and if you try to do this particular thing, it will take n into k time complexity, and both are 1e5, so you will get a deal. It's really great if you have solved the fourth one. Almost solved, because it was quite like not standard sliding window. But I will explain you in the same way as sliding window. Okay, so don't worry about that. Alright, so let's start. Okay, what is my sliding window key idea? For a variable size sliding window, and you are working on frequency, so you will make a map to store frequencies. Okay, the key idea of sliding window is you make a while pointer while end is less than n. So I'm writing the template of variable size sliding window as we have done in an earlier post context discussion, like a previous post context discussion also, where I have always tried to make sliding window in form of some template which comes with increase sorry, grow your window. Okay, shrink your window, then answer update, and your end plus plus. Okay, so these are the 4 steps that we basically use in variable size sliding window. So for grow the window, how can I grow? I need to take care of 2 conditions, right? So let's write. So this is my form of sliding window. I will write how can I grow this window. To grow this window, I need to keep the frequency of this particular numsend. Okay, keep the frequency of numsend. So I will increase that into our map. Okay, take your map and put the values into the like map. So we will increase the frequency one by one. So map of nums and plus plus. That's what we are doing. Okay. All right. So all right. So this is clear. Now I have to maintain distinct also. Okay. So if this value is not in map already, not in map, so I can increase my distinct count to distinct plus plus. Yes or no? Okay. So this is true also. Now I have grown my window. Now let's shrink. How will you shrink it? While your distinct count is greater than k, just shrink normally. So what we do, map of nums start minus minus, and if it is 0, then you decrease your distinct count also. So if this map thing is comes out to be 0, then you decrease your distinct count also. Okay, so one value has been decreased from your map. Yeah, just try to okay. Distinct count minus minus. All right, so I have shrinked my window also. Comes to answer update. Here it is tough. How will you update your answer at this particular point? Is it and minus start plus 1? No. While we are counting, this is standard that we add and minus start plus 1 into our answers, and answer will be updated. But we have one more condition, which is m. Each frequency must be equal to m. Okay, so I need to maintain frequencies also. Okay. What I can do at this place? Look, let's take one example, okay, to visualize it. Is for k is equals to 2 and m is equals to like 3. This is my valid window. Okay, this thing is my valid window. Correct. Now, oh sorry, frequency is 3, right? So let's take this here and say. So this is my valid window. Now it says m should the frequency should be at least m. The frequency should be at least m. No, why no? This is not my valid window right now. 2 1 2 1 2 1. Frequency should be at least m, right? Right now, yes. Okay. Frequency should be at least. Okay. So this is my valid window. This is also my valid window. This is also my valid window. This is. These all are my valid window. But if I put 4 here, it is not my valid window now. So till here, I have valid windows. Correct. And this is the last point for valid window. Okay, so let's write it properly. I will make like, take this red pen and mark this point as last point for valid window. Okay, and this is my first point for valid window. Yes or no? Is this clear or not? This is my first point and this is my last point. Is this clear? Can I write it like name the both of the points as first and last? Okay, if I can name them now, we do and minus start plus 1 because my window can be converted into any subarray. Okay, but here I can convert this window I can take this window into any subarray. Correct. So my answer will only be updated by the last point minus first point. Okay. So these are the all valid uh, subarrays that can be formed with k is equals to 2 and m equals to 3 for this particular valid window. correct? Only these values are there for this valid window, and these are not. Okay. Although you can add your answer with this value, and what we usually do in like standard sliding window approach, where you have a valid window with start and end marked as, and you say all of these values are valid. Okay, so this is for a standard window. But here the idea is same, but your window might be larger and your valid window must be a smaller part of that. Okay, as you can see in this particular like example, this whole complete thing is my valid window. This whole is my valid window, but only this part can be used for answer. Okay, is this clear? Is this crystal clear right now? Okay. If this is clear, then I can write my answer update is last minus first. Yes or no? Now I have to maintain last and first always. Okay, so don't take stress about that. I will maintain last and first. Now I will show you how I maintained that. Okay, just tell me, is this clear or not? But that repeating part can never occur on the right part. Which repeating part? This part. Which part it is? This part you are saying cannot appear on the right part. What do you mean by that? Yeah, okay, so this part cannot be occur in right on the right part, which means on the right here. If you're saying here, yes. Oh, I just came. Could you? It can even occur. Oh, so it can occur here. Are you saying about that? Okay, so I will just revise all of the problem, like the complete problem in one go. Just wait a minute. No, not cannot. Look, if it is occurring here, then this particular part will be like you are just saying if this part is on the right. Okay, so say it was like 1 to 1 to 1 to 1 to 1, and then you go 1 1 1 1 2 1, right? Yes or no? Are you saying this? Then what is your valid window? Current valid window, it is k for k equals to 2, m equals to 3. So you go at least 3 2 you have. Okay, okay, so this is your current valid window. Okay, okay, so this is your minimum possible valid window. Now these are extras, so your windows can extend up to here. So if you say 4 was here, so your window can extend up to here. Now these are the only values where your window your subarray can like move or according to him. Okay, so these are the only values where subarray can move, or it can increase, it can decrease on these two values. So my answer will be the number of combination of this, which is last minus first. This is the last value, this is the first value that occur, so it is just last minus first. Yes or no? Clear or not? Is this clear now what I'm doing? The key idea of subarrays in sliding window is when you count subarrays, it is start minus end, and you say all the values in that is valid. But here the minimum valid you can have is the last point, and the maximum valid you can have is the first point. So you just do the last minus first to count the number of subarrays. All right, so I got my answer also. Now answer is last minus first. Oh wait, how can I count last minus first? What is my last and what is my first? Look, now look. Your last value is all the values containing k is equals to 2. Clear? And your First value is all the values which contains k is equals to 2 and m is equals to 3. So this is your bubble. Here you go, k is equals to 2, which I have already calculated in the frequency, like distinct is greater than 3. So I have made a map and this is calculated. Now I have to calculate the bigger bubble. So for that, what I'm going to do, look, I will make one more map, store the same thing, okay, store the similar thing, and here you just count, you just check for m, okay. Here you are not counting for distinct, here you will check for m, okay. So make another map, map 2, same, increase the frequency of num set, okay, increase frequency of num set. Alright, now you will work for m, okay. So you make another counter. So I can say I will make another counter which is count for m, and here I will count like I was counting distinct. I will similar way count for m, okay. Now in the same way I was shrinking this. I will make another one while your like the value count of m is greater than k, okay. So greater than equals to k, so you can just have exactly k. So if there are multiple values, you can just decrease your like similar way you decrease your map of nums and map 2 of nums and map 2 of nums, and then if it goes to like again comes to m, then you increase your like value in the same way, correct. Now you will get now you have to maintain two starts at this point. So nums of and not nums of and. You make start. So you need to make two starts. So let's make it start one and make it start two. Okay. So you have two starts now. So last and first will become start two minus start one, or whatever is the maximum one. Okay. So I can write it like this. Okay. Now my sliding window is done. Let's look at the code now. Okay. Sorry. Look. This is nothing. There are two maps. Okay. There are two maps. There is a distinct counter. There is an end starting with 0. There are two starts starting with start 1 and start 2. And there is a count, which is count for m. Okay, so let me write this value. Distinct counter. This is count for m. Right. Now, while your end is less than n, so this part is grow your window. This part is your shrink your window. Let me write just. So this is answer update and n plus plus, as you can see. So all the sliding window sliding window problems can be solved in this manner. Okay, if it is a variable size sliding window problem, you can solve it in this manner. Now what I've done for the map one, I will put for k, and for map two, I will put for the bigger bubble. Okay, so map one, num set is 0, which means it is a new value. So you will increase your distinct counter and increase the frequency in your map. Now if you like put the similar value in the map 2, okay, now if your map 2 comes out to be equals to m, now increase your counter for m, okay. So you count for m. So I have got m. Now I have increased it, how many values I have. All right, so now shrinking of window, if your distinct count is greater than m, decrease that start pointer and decrease the distinct count if it gets to 0 and start plus plus. Easy thing. Okay, now same for that m thing, count for m. You need to have at least k values. Okay, so you will make, if your counter is greater than equals to k, then you will shrink it. Okay, shrink until you get m minus 1 values. Okay, so if you get m minus 1 value, decrease your counter like counter for m, start to plus plus. Now if your start to is greater than start 1, then you can just say your answer will be an addition of start 2 minus start 2. Okay? Then you increase your end. That's it for this problem. Is it clear now? Is this clear? Very clever. Why? Is this done? Any doubts? Sliding window got confusing. It is not the standard sliding window, right? Okay, so divided equals to 2, m equals to 2. Okay, no problem. So, what was your 1, 2, 1, 2 is equals to 2 and n equals to 2. Okay, so this is the case. Right, let's make two map and distant counter is 0 and the counter is 0 for m. So these are all the values. My current all three pointer will point here. This is start 1, start 2 and end. Now you got one. The map 1, this is map 1, this is map 2. Map 1 don't contains 1, so I will put that, increase my distinct counter. Fine. Now you got 2. 2 is not in the map again. Sorry, don't make 2. Put that into map 2 also. Okay. Now, is that frequency equals to like 2? No, it is not equals to 2. So I will not increase my counter. Now you go for 2. Oh, I'm always forgetting that. Now you have to shrink it. Can you shrink it? Is it greater than k? Is your distinct counter greater than while? Where do we have while of part of the code? Because I have just told you like here you need to maintain two things, which is first and last. What does the last thing defines? Last pointer defines. It defines that you have exactly k values and exactly m frequency of each. Okay, so this is your exact thing. Now your first pointer defines. Let me write it somewhere. Your last pointer defines exactly k and exactly m values. Okay, m frequencies of each value. Okay, your first pointer defines exactly k, but any m. Okay, any m frequency which is greater than m, obviously this is greater than m, so any m frequency. As you can see here, until up till this point, you have exactly two values and each of them has frequency 3 or greater than 3, at least 3, which is at least 3 or exact 3 for 2. For 2 it is exact 3, which means there is one element which has exact 3 frequency. Now for here you have still have k is equals to 2, but you have a frequency more than m. Okay, so how much you can extend this will tell you the number of element you will have in the middle. Okay, so that's why one bubble is of k is equals to 2 and the second bubble of k is equals to 2 and m is greater than equals to 3. So these two bubbles are there, so I need to decrease them, both of them. Okay, now just look. Okay, so for this, I have put that in the. If I shrink it, is my distinct count greater than k? No, it is not. Is my count is greater than k minus 1 or greater than equals to k? It's still not. Okay, so let's move ahead. My answer will be like start and 0 is 0 0, so answer will be like 0 only. Now your end is here. Not your end is here, but the pointer end is here. Okay, so you are at the second point. Now put that into map. So it is a new value. So I will increase my distinct counter by 2. Put that into map 2 also. Still the frequency is not equals to like greater than map. So no problem. Now you see, is distinct counter greater than k? No, it is not. Is my count is greater than k minus 1? No, it is not. Okay, so I'm not moving. I will move ahead. All right. So here Here I got frequency of 1 S2 and my 2 has 1 frequency. Now distinct counter won't increase because it is already present in my map. Here you got frequency of 1 S2 and frequency of 2 S1. Now this frequency is equals to m, so it will increase your counter. Okay, great. Now is this greater than k? No, it is not greater than k. Is this greater than k minus 1 or greater than equals to k? No, it is not. Alright, so move ahead. Here. Now your end pointer is here. Where is it? Now you increase your count of 1 is 3. Then you increase your count of 1 is 3. Okay, if your count of 1 is uh, is 3, it won't increase your counter here because it is counting all the m values in the array. Okay, right. So your distant count won't increase, your count won't increase. Okay, so that's fine, no problem. Now you go at 2. Okay. Now you go. Now if you look at 2, the frequency of 2 will increase. Okay, frequency of 2 increased. Now frequency of 2 will increase here also. And if it is equals to like m, now it is equals to m. So both of the values are equals to m. So there are two values which are equals to m. There are two values in my map which are equals to m, which is k. 2 is k. So which means there are two distinct values in my map which contains frequency as 2. Now this pointer s2 will start moving now because count is greater than 2. Now if your count is greater than 2, you will decrease it. Okay, so you will increase your counter. How? So you will increase your start pointer. How will we do that? It is while your count values is greater than equals to k, which means you got k values or more than k values which are which have frequency of n. You will try to decrease them. Okay, now you will try to decrease them. How? So you move your you remove 1 from your map 2. So the frequency go to, is it m minus 1? No, it is not m minus 1. So it will not decrease because which means the window is still valid for me. So this window is still valid for me. Okay, as you can see, and it is true also. This window is valid. It has k equals to 2 and m equals to 2. So it is valid window. So I have decreased that. My count won't decrease. Okay. So I will move my start 2 pointer here. Now I will decrease this again from my map. Now this will become 1. Okay. Now this is not a valid window because m this value becomes m minus 1. So I will decrease my count. So count to 1. Okay. Now if your count gets to 1, what will you do? You got that point where you have to like say the window is not valid till here. Yes or no? Is clear till here? Is this clear till here? Now this is decreased, so this will break out. Okay, so your start 2 is here and start 1 is here. Clear? Now your answer will be updated. Start 2 minus start 1, which is 1. So now answer is correct and answer is 1. Okay. Now if this is done, then you can just move your end again. Start moving your end again. So just tell me what was that? I have done here? How I have done here? Okay, look, I have just told you above where it is. So here, as you can see, I just told you like this. If this is my valid window, which is the smallest valid window, I can see how much increase I can have of that window. Okay, how much increase I can have, which is the maximum valid window I can get. So look here, the similar thing is happening here. This is the smallest valid window, right? This is the smallest valid window till the end pointer. Now this is the just the increase you can have. This is just the increase you can have. Now the number of valid windows is just s2 minus s1. That's what I was saying, right? This is the only part where you can just shuffle your window and get the number of windows. Okay? Yes or no? Yes or no? That's what I mean, right? At that point, do you understand this? The concept right here. Okay? Do you understand this particular thing? Now, if you move your pointer, increase your hand, then you got one. Increase your frequency one here. Increase your frequency one here. No frequency will be updated. No distinct count will be updated. Your answer will still remain the same. Okay, because your start is at point 2. Now look, when you increase or like answer will be updated, right? Because S2 and S1 is different, so your answer will be updated. So it will become 1 plus 1. Now your end will increase to 2. Now for this, you will increase the frequency of 2 as 3, and here you will increase the frequency of 2 as 2. Now as you can see, this becomes 2, so count will increase. Will increase to 2. Now this is my smallest valid window now. Yes or no? This is my smallest valid window now. Now I will check how much I can make. Okay. So I will decrease my start to pointer, take it to the smallest valid window. It will come up to here. Okay. My start to pointer will come up to here. You can just look, and then this is your smallest valid window. It's just S2 minus S1, which is 1, 2, 3. Okay, so 0 minus 3. So comes up to 3. So you can add it will give us 5. Okay, then your end will go out of the boundary. Okay, so this is the key idea of the problem. If I just test it, if I'm not wrong, it was 1, 2, 1, 1, 2, 1, 2. Let me test it. 1, 2, 1, 1, 2, 1, 2. Okay. Case 2 and 2. This is the first case 1, 2, 1, 1, 2, 1, 2. Answer should be 5. Oh, answer is 8. Wait, I was missing something. So you got 5. Then you increase your pointer again. Like, is there something missing? Is there something missing? Like, I'm not able to add one more value. One more 3 should be there. This is your smallest valid window till here. Then you add this thing. It might be a dry run mistake somewhere, because you increase, then you get 3 as your output, and your count will be decreased by 1, and your 1 will go to 1. Okay. It might be some dry run mistake. We can do it again. Right, so if I want, I can do it again. 2, 1, 2, and minus 2, case 2, 2 maps. Yeah. 2, 3 pointers. Then you go S1, S2, SE. Add it to the map. Distant count is 0, count is 0, then answer is currently 0. 1 is added as frequency 1. Then you increase the counter because nothing has been increased. So this is just 1. Now you increase the counter pointer here. 3. Then you add to 1, increase your distinct count as 2, then you add to 1 again. Nothing is valid, so increase your 1 here. So the frequency will be increased. Then frequency will become 2. So count of is it is 1. Now increase your frequency again, which comes out to be here. Alright. So now you increase your frequency to 3, then you increase this also 3. Distinct won't increase, count won't increase. Now you increase your end to here. So 2 becomes 2, then this becomes 2, and you get one more count of m, so it will become 2. Alright, so now I can decrease. How I can decrease? I will decrease start pointer, move your start pointer, take it 1 from here, it will become 2. It's still valid. Okay, so dot s2 will come here. Then you take 2 again from here, then it will go 1. Oh, I was not increasing s2 one more time. I got that. Oh, I was stopping it here. It will go to here, right? Because of while loop, because of this particular thing, it will increase even after your m becomes minus. Oh, yeah, that was my mistake. So your s2 will come here to here. Okay. Now your answer will be updated by 2. Okay. Answer will be updated by 2 at this point. So that's what my fault was. Okay. Now you will increase your end again and go up to here. Uh, this will increase by 2, 4. And here you have 3. Now it will get increased again. So your distant count won't increase, it is 1. So you will go at here and equals to here. So your frequency is 3, then your count of value is 2. Now you got count of value is 2. Now you will start decreasing your start again. Okay, so you have added 2 again. So we will start decrease for the particular previous one. Start decreasing it. Okay, so you will decrease this value. So 1 becomes 2. Okay, so it comes here. Now uh, your 1 becomes 2 again. So this will decrease. Like this was 2, so it will decrease. It will come here 1. Then you decrease it again. So it will come to here and it will become 1. So s2 is here. So this is then 4. So yeah, 2 plus 2 plus 4, it is 8. Okay. So yeah, I was like doing a singular mistake there where I was not increasing my s pointer by at least 1. So it will increase it in the same manner. This dry run is correct, but s2 pointer will like go one more movement ahead. Due to this, it is after decreasing and in the count, it will still increase. Okay. So yeah, this was the whole approach. If you understand this, just write a comment. If you need another try, you can just write it again also. Okay, I think this is clear. Any doubt in any of the problems? I saw it's not like very typical to like know. I just know one thing. Each of the sliding window problem can be solved in these 4 ways. I just need to write, grow, shrink, answer, update. Only these 3 things need to be maintained. Okay. At each point, at each point, you will just when you try to solve a lot of problems in sliding window, then you can just get an idea. Like in grow, we usually just increase your map or whatever it is, count, user count, or anything which is asked. In shrink, we will do the same logic, which is while something is less greater than something which is given. Increase your particular num start value from something like and increase your start pointer. And answer update, if you are asked for count of subarrays, it is always end minus start plus 1. Nothing else. Okay, so yeah, this was the key idea of the problem. Is this clear? Now, anyone has any singular doubt in the problem, like anything is not clear, or you want a try run on another test case of your choice? Else, this is the whole code, the key idea of the code. Similar thing, grow your window, shrink your window, answer update, and end plus plus. Can you show your code of answer? Yeah, here, as you can see. This is the distinct counter. You have a counter for m. Count how many values have m frequencies or greater than m frequencies. Then you go grow your window. Grow in the same manner. If it is 0 in the map already, increase your distinct so it is a new value. Then put that into like, your map. Increase the second map also with the same frequency. If it gets to m, which means your nums and frequency is m, so increase your counter for m, right? Uh, just just no, it is not physically only visible. How can I write that profile? Why you want to see my profile? You can go to my LinkedIn and just check from there, visible there. So then you can just shrink your window. How? If your distinct count is greater than k, you will shrink it because you want exactly k distinct. So this is the distinction, decreasing or distinct. And if your frequency is like greater than k, yes, I'm in my third year. So you can just check for if there are frequencies which are greater than equal, like greater than equals to m. You will decrease it to find the smallest possible like uh, subarray which is valid. Okay, smallest possible subarray which is valid. Now, if you get that, just decrease until the value satisfies, and your answer will be like the difference of both of the points, that 2 minus that 1. You can write it like this also, and this should be valid. Okay. This should always be valid because your status must be ahead. Last pointer must not go before front first. Yeah, that's it for this problem and for the post contest discussion. I hope you were able to understand all the codes and try to solve them. It's quite easy, and if it is not easy, then you will ultimately get some new ideas to like wonder and solve upon. For sliding window, I will just suggest you try to solve hard sliding window problems which have variable size sliding. You can just um, ask even like type in the Google sliding window problems, then you can get some of them, or you can just go to Leetcode section of sliding window, then you can get from there also. Okay, uh, that's how you can just try to solve these kind of problems. And that's it for this. Thank you for joining, guys. We'll meet again in the next post contest discussion. I hope very soon. And thank you for joining. Bye bye. I hope you were able to understand the problems.